So in your notes today, we talked about linear equations, we talked about linear systems, and what we're going to work with today are nonlinear equations, lines that do not make straight lines. And the three types we're going to deal with are those that are made when you use absolute value, which will look similar to a v. Also those that are made when you have x squared, which will make a parabola shape. Later on, we're going to deal with a shape called a hyperbole. But today we're going to concentrate on the v shape made by absolute value and parabola made by x squared. So in your books, please look at page 442. And for those of you that are watching on camera today because you're absent, it looks like this, graphing nonlinear relationships. And you're going to read page 504 and 505. I just looked at that. So turn in the book, please, page 504. And David, I think you can put the camera right down on the table if we do this right. Will it still be able to get the thing or not? Can you see through there? Nope. Okay, bring it up here. Try it. Let's try it here. Now, can you see? Is that getting it? All right, let's try that. Okay, so for those of you joining us on video, I hope this comes through. This is our first attempt. So in real life, there's lots of times that lines are not straight. If you look at page 504, the first one they show is a soccer ball. Many of you have played either soccer or football. In either case, we know that the object is to get the ball up, and we know it's going to come back down. Also in golf, you can see this kind of a parabola. So in real life, things often have a curve like that. So when we look at this example, it's called a nonlinear equation, anything that is not a line. If you look down at example 1, graphing a nonlinear equation, you'll see that the formula that they're using, or the equation, is y equals negative x squared. So they made a table from -3 to 3. You can look either at the screen or in your book. -3, so the negative, or the opposite of -3 squared, would be -9. So we have -3, -9. And you can see they finished the table with all of these ordered pairs. Then when they graph them, it makes a shape that's a U shape. Notice the arrows on the ends, because that means that this shape goes on to infinity, just like a line does. So all of the things not shown on that graph are also going to be part of the solution set as it continues to go on. So now it asks us to make our own table. It says graph, please, y equals 2x squared using integer values for x of -3 to 3. So the first thing we have to do is make our 4-column function table so we have ordered pairs. You may do this in your journals on lined paper. Okay, now to start. Our first column is x. Second column is going to be the rule, which in this case is 2x squared. Then y, and then our ordered pair. Okay, we're videotaping right now. Hugo, go ahead and go for testing, and then you'll have to get the lesson online. Okay, so then it told us to use -3 to 3, so here we go. -3, -2, -1, 0, 1, 2, 3. Where did I know to use those for x? Because it said in the book. Good. All right, so now we're going to plug those into this equation. Well, -3 squared. Go ahead and talk at your tables about that for a minute. -3 squared. How many of you got -9? Well, let's think about that some more. -3 times -3 is a +9. Okay, so here we go. So we have 2 times 9. Let's go do the same column all the way down. How about -2 times -2? What do you have? +4. So now we're going to have 2 times 4. -1 times -1 is 2 times 1. 2 times 0. Because 0 squared is 0. How about 1 squared? What's 1 times 1? 1. So we have 2 times 1. What about 2 squared? 2 times 2 is 4. And then 2 times 3 squared, 3 times 3 is 9. Are you noticing that we start with 2 times 9 and end with 2 times 9? That's because of the rule about the negative times a negative is going to be a positive. And that's the whole reason that x squared makes this shape. That's the combination. So 2 times 9, we've got 18. 2 times 4 is 8. 2 times 1 is 2. 0, 2, 8, 18. Now ordered pairs. Negative 3, 18. Negative 2, 8. Negative 1, 2. 0, 0. 1, 2. 2, 8. 3, 18. I'm going to take a break there just a minute and let you make sure that your table is caught up. Now, for this one, we have to go to 3 and negative 3 all the way to 18. So we are going to need a piece of graph paper. I'm going to stop the video for just a minute, and if I could have you all get a piece of graph